Today we're going deep beneath the surface of Romania to explore one of the strangest and most isolated ecosystems on our planet, a place cut off from the outside world for millions of years. This is Mouville Cave, a subterranean world unlike anything you've probably ever heard of. And here's what makes it extraordinary. Right now, there are scientists who know the surface of Mars better than they know this place. Mouville Cave is a karst cave system near the Black Sea, discovered only in 1986 during construction work. Since then, it has become a scientific treasure trove because its environment is completely unlike anything above ground. Unlike the air we breathe, which contains about 21% oxygen, the air in Mouville Cave contains as little as 7 to 10% oxygen. Scientists have measured dangerously high levels of carbon dioxide, hydrogen sulfide, methane, and ammonia, gases that would be toxic or deadly to most surface animals. Combine this with pitch black darkness, 100% humidity, and no sunlight for millions of years, and you have an environment that seems almost hostile to life. And yet, it's teeming with it. Because sunlight never reaches this cave, organisms cannot rely on photosynthesis, the process that powers nearly every other ecosystem on Earth. Instead, life here runs on something called chemosynthesis. Chemosynthesis is a process where microbes derive energy from chemical reactions, in this case by oxidizing hydrogen sulfide or methane to produce organic matter, essentially forming the base of the food web without sunlight. At the heart of the Mouville Cave ecosystem are chemosynthetic bacteria. These microbes form thick microbial mats that line the water, sediments, and walls of the cave. These mats are more than biofilms. They are the foundation of a complex underground food web providing the first level of energy and organic matter in a world where the sun never shines. Where we see plants capturing sunlight, here bacteria captures energy from chemicals. It's an ecosystem that mirrors hydrothermal vents deep in the ocean, but it's on land. Because the cave has been sealed for about 5.5 million years, populations inside have evolved in complete isolation. Today, researchers have documented over 50 invertebrate species: insects, spiders, water scorpions, woodlice, leeches, centipedes, and many more, with most of them being completely unique to this cave. Most of these creatures have never seen sunlight. Over generations, they have lost their pigmentation and evolved without eyes, because in total darkness, neither color nor vision provides a survival advantage. Among the most remarkable animals is an endemic centipede, known colloquially as the king of Mouville Cave. Cryptops spilorex, which reaches several centimeters and hunts smaller cave invertebrates. And then there are the cave water scorpions, Nepa anophthalma, an extraordinary example of an arthropod adapted to a life completely divorced from surface ecosystems. Now you're probably wondering, how did life get here? Well, that's still a mystery. Some animals likely entered the cave early in its formation, when passages were connected to the surface. Others may have arrived more recently. What is clear is that once sealed, these populations adapted to their extreme environment over millions of years. This isolation, lack of sunlight, and reliance on chemical energy created an evolutionary pressure cooker. Organisms had to adapt to darkness, low oxygen, and chemical energy sources far different from anything above ground. As a result, Mouville Cave provides unique insight into how life might evolve on other worlds without any sunlight, such as beneath the icy crust of Jupiter's moon Europa or Saturn's moon Enceladus. Research teams from around the world have studied Mouville Cave since its discovery, and access is highly restricted to protect its fragile ecosystem. They've found that bacteria, protists, fungi, and invertebrates form tightly linked food webs powered by chemical energy. This has challenged long held assumptions about the necessity of sunlight for complex ecosystems. Mouville Cave shows that if you have an energy source, even one as unusual as hydrogen sulfide, life can find a way. Mouville Cave isn't just a scientific curiosity. It's proof that life on Earth can adapt to conditions once thought uninhabitable. It broadens our understanding of biology, evolution, and the potential for life on other planets. In a world where biodiversity is constantly threatened, Mouville Cave reminds us how fragile and unique life really is, and how much we still have to discover about the hidden corners of our own planet. This underground world, sealed off for millions of years, continues to teach scientists that life is far more resilient and far stranger than we ever imagined. And that's the Mouville Cave, a world without sunlight, yet full of life. If you enjoyed this video, leave me a like and don't forget to push that subscribe button. Thank you.